Hi there, this is Abhishek, and in this video I will talk about how you can identify the issue of heteroskedasticity, which is basically a violation of one of the assumption, homoskedasticity in linear regression. I know the term sounds a bit long and daunting, but let me explain you in a very simple term so that you can understand it and easily relate it when it can occur. So let me go to here on this. Homoskedasticity is here and heteroskedasticity is here. So first thing is that assumption is that the data should be homoskedastic, and the pattern is basically called homoskedasticity. What it means is that for the residuals for a given predicted values, the variance between the residuals should be constant. If it is not constant, then it results in the violation of the assumption of homoskedastic data, which is called heteroskedastic. And in that case, you get kind of a fanning effect. If you see, when the predicted observations are becoming larger, the variance is also becoming larger for residuals. So homoskedasticity is an assumption that it should be present. When it gets violated, it turns into heteroskedasticity. When you see homoskedasticity, there is an equal variance in the residuals, but when you see the heteroskedasticity, then it's the increasing constant variance into the residuals for the given predicted values. Now, that's pretty much about the technical term. So when it can happen in the real life. So let's take an example of the traffic police and the traffic violator, and they collected the data for the different age groups and the bikes that they had. So what happens is that they observed when the biker was younger, like in this case, let's say the biker is 20 years old, they are seeing that there is a large number of violations that is occurring. And when it is going towards the age of, let's say, 35 or 40 years, then in that case, in some cases, the violation is large, and in some cases, violation is less. So why it happens is because when people are younger, they thrive with the more speed and tends to violate the law pretty regularly. But when somebody matures and reach to the age of 30 or 35, then in some cases people may violate the law, and in many cases people are not violating and wants to live a normal life. So what happens in that case is that we are seeing the issue of heteroskedasticity. If homoskedasticity was present, then there should be not much variance or no increase of variance irrespective of what age is. And that's what homoskedasticity says, that even if age is increasing or decreasing, the variance of the residuals should be same. But in case of heteroskedasticity, when it violated the homoskedasticity and turns into heteroskedasticity, when the age is increasing, either the value is increasing or decreasing, the variance between the residuals is increasing or decreasing, and that's actually result into the heteroskedasticity. Another example I will give you is the one which you can easily relate. So most of you have experienced the iPhone sale by standing in the queue and really looking forward for your new iPhone. And in that case, whenever the new iPhone is launched, there is a high sale, right, for each of the Apple store. But as and when the product gets old, either sometimes when they run the promotion, the sale is higher, or if it is like a normal day, then it can higher or lower, depends on the user requirement. But what homoskedasticity is saying, that irrespective of sale or a new product launch or anything, there has to be no variance or constant variance between the residuals, the errors, that means the actuals and predicted values. And if it is not true, which is basically a case of heteroskedasticity, then you have the not so constant, or I would say unequal variance of in the residuals. So now you would have understood by these two examples that in general cases, in normal data, you will definitely have the issue of heteroskedasticity, and it's our responsibility then to see whether it is very much apparent or it is very less that you even think it's not going to affect, or you are not even able to identify whether heteroskedasticity is present because data is like normally distributed or having a constant variance. Alright, how you can do that? It's pretty easy. If I go back and show you, so as I mentioned, what we need to have is basically two values, the residual values. We need to plot the residual values against the predicted values and see if there is a constant increase or decrease variance, constant variance, or an increase or decrease variance. So what we can do is we can say plt dot scatter, and we need to have x-axis as y underscore red, and another value is residual that we created in the earlier video. If you have not seen, I really recommend that you do see that, because we calculated all y pred and residuals. And if I plot it and go down, so on the x-axis you will see that you have the predicted values, and there you have the residuals. Residuals is nothing but observed minus predicted. And if you see, there is some sort of a pattern that when the values are predicted values are less, then there seems to be a high variance. When it is somewhere in the middle, there is a less variance, and when you are going towards the right, there is again a high variance. And if you see, there is a shape like this, kind of a curvy shape, and in that case you really need to test the model whether it is predicting the right or not, or by even testing the hypothesis that the problem of heteroskedasticity is present, or your coefficient, by testing the coefficient using the hypothesis testing. And what you would usually do in such cases is you transform the variables, either log transformation or change the equation from a normal ordinary least square to let's say quadratic regression. So in this case, probably because it's a curvy shape, then in that case you would look towards more of a quadratic regression technique. So those are more about transformations. I will cover in the couple of next videos about how you can really transform with the log transformation or quadratic regression and all. But just to give you an idea, generally you will have this situation present because in real data you have a lot of variance, and if it is apparent like this, for smaller predicted values there is a high, for a higher value there is a high variance, but down there it's not so high, and kind of a shape that it is picking up is this curve shape. So if you find such a pattern, then you would really look towards testing your solution. Another thing is what you can do is for residual, for this prediction we have taken a lot of variables, right? If you see, if I go back, we have taken almost all of the variables, in that case the 13 variable, and what you can do is you can try and remove some variables which are not giving you the accurate values. And how you can do that, I will show you in next video about which variable really make a significant contribution by looking at the p-value there. So p-value is basically an indication, a straightforward indication that whether some variable is making a significant contribution or not. If it is not, what we can do is we can simply remove it from our equation, and then do all these different testing, like we did mean squared error, we did the independence of error, normality of error, and then in this case we did homoscedasticity and heteroskedasticity assumptions checking. And if any of the violation is not happening, like in that case normality of error and independence of error was not there, we simply moved ahead and checked it for the homoscedasticity violation, which is heteroskedasticity in turn. So you can remove it and again test it for all these assumptions. So that's pretty much all I have for you in this video. I mainly wanted to give you the idea of homoscedasticity and heteroskedasticity. I found it little confusing in the start, but I did a lot of reading and figured it out in a very simple way with the help of traffic police example, as well as with the example of your Apple sales. Another third example which I can give you and you can relate it is when somebody is making a high expense or low expense. So expense is highly related to income, and when the income is large, you tend to do the more expenses, but that's not true in all cases. Why? Because you will see that some families are more responsible, they save the money and don't do a lot of expenses, but in some cases people do a lot of expenses once they acquire wealth. But in case of those families which are having low income group, they don't have the liberty of making a lot of expenses. So those low income group is basically a constant variance, so it's a homoscedastic. But those which are having a high wealth is basically a heteroskedastic, because it depends on family to family and whether they want to spend the money which they have earned or they don't want to. So you will see that there is no constant variance, and there is a differentiation of variance between the residuals when you plot it against the predicted values. So just gave you the third example. Hope it made it more clear, and I will meet you in the new video with a new topic.